Welcome to the video recording of projects in F# for Xamarin University. My name's Glenn Stevens and I'll be taking you through today's course. And before you begin, there'll be a number of exercises that we'll be going through, so you want to make sure that you've downloaded the class materials from university.xamarin.com. Okay, let's get started. In the first class, we focused on the F# syntax and typing in F# code using the REPL, our interactive environment. In this class, we're going to move on to building full applications with F#, where we create a redistributable binary assembly that's executed using either .NET or Mono. And we've got two objectives for this. First, we're going to examine the structure of an F# application project. And you'll find that it's very similar to projects that you've worked on in C# in some ways, and drastically different in other ways. Next, we're going to examine the pieces that make up an F# application itself, and that includes namespaces, types, and modules, and how you can define and use them. So let's start with the F# application structure. And first we'll examine the included project templates for F#, and then we'll talk about two different types of files you can include in projects. And just like C#, your IDE, whether it's Xamarin Studio or Visual Studio, includes a set of templates, and you'll use those templates to generate your initial project structure, and you'll select a project type based on what you want to create. And all of these projects are similar to the C# projects that you use today. And one of the interesting ones that you won't find in C# is the tutorial application. And this is a special project template that generates a bunch of boilerplate and example code for you to explore. And it shows you some F# syntax, built-in APIs, and common patterns that you'll use when you're writing F# code. So let's take a closer look at the tutorial project by creating one and actually walking through some of the code. So let's create a new F# project in Xamarin Studio. So I'm going to select a new solution, and from the other .NET, you can see I've got the F# tutorial option down the bottom here. Now if you're using Visual Studio, you'll find the F# tutorial there as well, and you'll find it just under the Visual F# node. So I've got the F# tutorial selected. I'll hit next. I'm going to place this project on my desktop. I'll just call this tutorial example and hit create. And that's going to create the project template for me. If you look at this tutorial.fs file, it's actually got a range of contents. You can see integers and basic functions, booleans, strings, tuples, the core data types. So some of the contents in this file you'll know, some of these you'll actually learn a little later in the F# series of courses with Xamarin University. You can see examples on how to declare things like integers, how to do basic functions, how to print content out, and there's lots of great examples and great content here. So it goes through the basic data types, how to do things like string manipulation, like concatenation, printing them out, how to do substrings, how to use tuples. You'll be introduced into tuples in about the third course. And likewise with the lists and list processing, how to define classes and interfaces, how to inherit classes, how to implement interfaces, how to use the basic types, and there's so many things that you'll learn as you go through the courses, but this acts really as a great guide, kind of like a cheat sheet, if you will. And one of the things I like to do is I actually like to save this tutorial.fs file somewhere on my computer, and if I'm doing some F# code and I need a concept, I can actually dock that file into the right hand side. You can do the same thing with Visual Studio, and you can use it as a reference as you're coding away. So we've just had a look at the F# tutorial project, and we've also seen that the project templates are similar to C#. However, the project structure is not. And in C# projects, any file can contain code that references any other file. And this allows for cyclic dependencies, and with large projects with a lot of code, it becomes difficult to track what references what. And this is especially true when you're new to a project. So where do you start? What's the first file you open your first day on a new project? And it's not obvious in C# because there's no implied structure or relationship between the source files in the project and the relationships between the code. Now in F#, that's not the case. There's a required structure that dictates how your code is structured. And this enforced structure causes our file relationships to be simple and uniform for all F# projects that you work on. And that means you'll always know exactly where to look when breaking into an F# application that you're unfamiliar with. So let's talk about the requirements. So first, F# projects have a specific file ordering. Rather than being organized alphabetically, they're organized by how they're used and what relationships the code within them have. And the rule is that a piece of code can only see code defined earlier. And you can see the effect of this rule in the relationship graph shown here. Each file can only refer to things in the files which are listed above it in order. And this is actually a really useful feature because it means that when a new developer joins the team, they know exactly where to start. It'll always be in the last file of the project. And there's a key programmer benefit to this approach. F# can now tell exactly what things your code should have access to, and it then provides complete IntelliSense and type inference to your code. And the type inference with F# is much more powerful than C#, and the specific file ordering is one of the major ways that this is enabled. So how do we adjust the file order in the project? In Xamarin Studio, you drag and drop the files around. And in Visual Studio, you use the context menu to move files up and down. And a second ramification of file ordering is the code contained in the files. Code ordering is important both in the project and within a single file. Code can only reference code that's above it, whether it's in that same file or another file above it. And as mentioned earlier, you'll always start with the final file in the project and in the last method in that file. And this makes it really intuitive to begin analyzing a new project that you're unfamiliar with. Our entry point in F# is a function that takes a string array parameter, argv in this case, and it's decorated with a special attribute. And take a note of the syntax where it uses the square brackets followed by the less than, ending with the greater than and another square bracket. And that indicates that it's the entry point. And this attribute tells the compiler to add the appropriate metadata so .NET and Mono know which function to launch when this app is executed. And the function returns an integer result code, and this is required, and you can't return null from main as the compiler will give you an error. And remember, we don't use a return keyword in F#. Instead, we just evaluate a value, in this case 0. Let's do a lab exercise. And in this lab, you'll reorder the files in an existing F# Android project to get it to compile and execute. The files in this project are deliberately out of order, and it's your job to reorder the project or reorder the files in the project to make your application build. So pause the video, do the lab, and when you're finished, come back and we'll review the project. So let's quickly review the solution. So here we start by looking at the individual files and see what files reference other files. So let's just open the files directly. And we'll have a quick look. Now, we can see in this code, because the to-do item fs is being referenced by the edit to-do activity and the main activity fs file as well, if we take a look at the code, it actually needs to be above those items. So we can move the to-do item up above. And because the app.fs class is also referencing the to-do item manager, we'll also need to make sure that the app file fs needs to be before the to-do item file as well, or after the to-do item file. And we've got our main activity, which is probably referencing the edit activity. So the edit to-do activity would need to be above that as well. And once we've got that in place, we should be able to build that project. So at that point, we should be okay to run the application. So let's quickly fire off an Android emulator and launch the application. All right, let's go ahead and run that. And our application builds and deploys. Awesome. And now that we've looked at the project structure, let's talk about the source files you put into the project. And there are actually two types of files you can work with in F#: script files and code files. And script files are useful when you want to run a small amount of code that you don't want to make into a permanent application. Script files have an extension of either FSX or fscript and can either be executed in the REPL by selecting the code and clicking Control and Enter, or with a command line tool like FSI, which is F# Interactive. And you can even build entire F# programs in a script and then execute them from the command line using the F# Interactive tool. And you can add script files into projects, but they're not compiled into the generated assembly. And this can be useful if you have some code that you're trying out, that you want to save or just use periodically in the interactive REPL while you're building your application. And code files must always be placed into a project structure and are compiled into IL just like any other .NET program. And code files always have the extension FS. And F# is a .NET language and it can use any existing assembly that you have access to. Just like C#, you have to add a reference to the assembly in order to access the code within it. With a project, you can just use the references folder and right-click to add references. For script files or when using the REPL, you have to use the #r command to add a reference. And you can just supply the name of the DLL and the system will locate it just like the references dialog. Or you can specify the full path if it's not in the GAC or along the assembly path. And with references, you can also reference Nuget components, and this works exactly like it does in C#. Nuget's not directly supported for script files or for the REPL. If you want to use a Nuget component in a script, you would need to download the component locally and add the reference directly from your local disk. So let's move on to a fun little exercise where we get the opportunity to use a Nuget package to create a PDF document based on a series of monkey images. And it should take you about 20 minutes to go through the lab. And like before, pause the video, do the lab, and when you're finished, unpause the video, and then we'll review the project. Okay, good luck. So let's just review the project that you just did. So our aim, if we look at the lab files, is to port some code to add a Nuget package, the Apatron image to PDF Nuget package, and then use some code to convert some images into a PDF document. So we've got our first line of code, which is actually F#. So let's paste that into our console application. And then we've got a series of code, which is C# that we need to port. So let's just select that code. And I'll paste that in. And if we have a look at this C# code, we need to convert this to F#. So we'll do some basic changes. So we'll move the types to the let statement. So we're going to use F#'s type inference. We're also going to remove the semicolons. We don't need those. And on our page settings instance, you'll notice that the scale mode and keep image orientation, we could actually change that to the assignment operator because these are actually mutable properties. So we need to use the assignment operator instead. And lastly, we've got the for each. We can change that to a for in. So for image in images, we'll add that document or add that image to the document. We're missing a do operator. I think that should round it off. We'll get rid of the semicolon. And then here, we'll use the document.save and then pass in the file name. So which should be the directory plus monkey pictures.pdf. And at that point, we should be able to go ahead and run the application. Let's do that. We've got an unsupported file format. Let's have a look here. And this is actually an interesting side effect. If I have a look at the file, you'll actually see that the image is picking up one of the hidden files. So we're not actually doing any appropriate filtering. So we're looking at the DS store file, which is one of the hidden files that you don't normally see. So we might actually change some of this code to be a little bit more functional. So if I take the code here for images, I'm going to move this down for a second. So we've got our images, and I'm actually going to get rid of the declaration, and then I'm going to pipe that into an array.filter. And here I can actually just filter the images. And just do a quick filter in that case. And that's going to be on the file name, so I might just use fn for the file name. And I'm going to do a filter just to make sure that the file name contains either a JPEG or the file name. Actually, let's use the ends with operator, PNG. So that's our filter. So only files that end with JPEG or PNG will get pushed through. And even after I have all those files, I can actually just iterate through those using the array.iter. And I'll use the image, and then they'll add it to the settings. So it's a nice little shortcut we can use, and it's actually a lot more functional. We don't need to declare the images variable. We can just use the output from the direct get files, push that directly into the filter, push that directly into the iter. So let's go ahead and run that. Cool, and we've got our PDF generator. Let's take a quick look. I'll open that monkey pictures folder. I can see that image. Let's just open it up in preview. It's working just fine. So I'm using the evaluation version of the Apatron library, but it gives you a sense of how that can be done. So let's move on to a quick flash quiz where we can see how much we've learnt so far. So in F#, files are listed A, randomly, B, to increase circular dependencies, or C, in order of use. And the answer is C, in order of use. Question 2. Script files can be included in an executable. True or false? And the answer is false. Script files won't be included in your executable. They'll be part of your project, but they won't be compiled into the end executable. Question 3. In F#, you can only reference code which is A, in a folder, B, in alphabetical order, or C, above the current code. And the answer is C. You can only reference code that's above the current code, whether it's in the same file or a file listed above it in the project. So that completes our current objective, where we've looked at the different types of projects, we've compared script files and code files, and we've had a look at how we can manage references and components. And next, we're going to look at the various pieces of an F# program and how you can organize it. And every F# program you create will consist of 3 basic things: namespaces, types, and modules. So let's look at each one of them in turn. Namespaces are used exactly the same in F# as they are in C#. They organize our code and ensure that new types don't conflict with other types with the same name. And we use the same keyword to define our namespace. However, there's no braces to define a block. Instead, it's always the first line in the source file, and it defines the namespace for everything that follows. And when you want to use types in a namespace, you utilize the open keyword. This is exactly the same as a using statement in C#, or at least the using statement that refers to the namespace variety. And you'll notice that we don't use quotes around the namespace name itself, nor do we have any semicolons. And remember, semicolons aren't really used in F#. The rules for namespaces are similar to C# rules. You can split a namespace across multiple source files. Each source file is almost always contained in a single namespace. When defining namespaces, you can use dots to separate different components for nesting, and you'd find new classes called types in F# within your namespace. And let's look at this next. And as we've said before, F# is a .NET language and has access to the broad set of classes defined both in .NET but also in third-party and custom assemblies. And to use these types, you simply need to add a reference and then use the open keyword to drag in the namespace. And then you can utilize classes built in any .NET language directly. For example, here you can see some code to read all the files from the desktop on a Mac and then iterate through each file using a for and do loop, touching each file to set its last access time. And we can also define new types using the type keyword, and this is equivalent to the class keyword in C#. And classes in F# always have parentheses after the type name. You'll see why we use the type keyword to define other things as well, and it's this characteristic that distinguishes this as a class definition. And when we create a type, we can execute some initialization code, similar to a constructor in C#. In fact, it's actually turned into a .NET constructor behind the scenes in the IL. But this is done just after the type definition and often consists of two statements that are called bindings. A let binding declares private fields, actually internal by default, and methods of the class, and a do binding executes code. So in C# it's very common to split classes by file name, one file per defined class, so you can easily find a class definition from the source file. And this is far less common in F# because of the file ordering enforcement. Instead, most programmers define all their types in a single file or just a few files. Now at first glance this actually might seem unorganized, but it turns out that we actually don't create custom types in F# as much as we do in C#, and we'll see why in a moment. And you just saw a moment ago that we can run some initialization code when the type's instantiated, and this of course is a constructor in .NET terms. In F# you're required to always define a constructor as part of the type definition, and the compiler never generates constructors for you. This constructor definition is called the primary constructor because it's always done as part of the type. So on the screen you can see two definitions. The first is a default constructor, which is one that takes no parameters, which executes a printfn statement. And the second one takes a single string parameter named subject and assigns this value to a field in the class named focus. And there's a couple of things to note here. First, you'll notice that we're supplying the type of parameter here by supplying it with a colon separator. And this is actually optional. F# would compile the code without our definition. However, the type inference engine can't figure out the proper type based on the usage because we don't have any. So F# will assume it's an object type, and supplying the type fixes that. Second, and this is interesting, if you were to use this code in a real program and go look at the generated IL using a tool like IL Spy or Reflector, you won't actually find any field. And that's because the field is private and not being used, and therefore F# will remove it as an optimization. And there's no way to change the visibility or apply attributes to let bindings. If we wanted to keep the field around, we'd have to assign it to a property. And we can define properties and methods on our types using the member keyword. And in this example you can see on the screen, we're declaring a person class with three parameters passed to the primary and only constructor. The first parameter, name, would be inferred to be a string because of the printfn statement where it's being used. The other two parameters would be inferred as object because there isn't enough information to figure out what type they should be. So the two properties DOB, representing the date of birth, and gender, would also be type object. Now to fix this, we'd have to declare the type in the constructor. And since they're only being assigned here, the properties would also be read-only. They would only have a getter exposed and would be backed by internal fields, which are assigned in the generated constructor. And members also used to declare methods in your custom types. And the syntax is almost identical, and the difference being what's assigned on the right-hand side of the expression. And here you can see a method called hello, which takes a string parameter, which is inferred, and then prints the parameter plus a name. So also in the code shown here, you'll see the word this in front of each member name, and this is a self-identifier that's used to refer to the current instance of the class.
Member is also used to declare methods in your custom types. The syntax is almost identical, the difference being what's assigned on the right-hand side of the expression. Here you can see a method named getName, which returns the name. We use the parentheses to force F# to evaluate this as a function instead of a property definition. And a second method named hello is defined, which takes a string parameter, which is inferred, and prints the parameter and the name. This needs no parentheses since it has a parameter being passed in, which F# takes to mean that this is a method definition. And finally, in the code shown here, you see the word this in front of each member name. And this is a self-identifier that's used to refer to the current instance of the class. So let's talk about that a little bit more. In F#, every non-static member definition must use a self-identifier. There's no requirement to use a particular word, just as long as it's consistent. And you could use this, which is the most common really, or self or me, or any other word that commonly indicates a self-reference. I think coming from C#, you probably want to use this, just so you don't confuse the two languages. As you've seen, every class has a primary constructor, created as part of the type definition. And you can also create secondary constructors with the new keyword. Unlike C#, secondary constructors must chain through the primary constructor, as you can see here. And generally, when defining types in F#, the primary constructor is the most complete version, and then we define secondary constructors, such as the default constructor, to provide the default values. When creating a primary constructor, we use the do binding to execute code. However, this isn't really available to our secondary constructors. Instead, we use the then keyword to execute code in our secondary constructors. When using this approach, you also have to define the self-identifier using the as keyword. F# can, of course, participate in inheritance, especially being a superset of C#. So it can even participate from types defined in other .NET languages. And we do this through the inherit keyword. This decides the single base class and also determines the constructor which is used to construct the class from our primary constructor. Here we're deriving from a person class, passing our name parameter through to a parameterized constructor on that class. We can also define new interfaces, useful for abstractions when working with other languages. We actually do this the same way we define a custom type, with the type keyword. The difference is that we don't have a constructor and therefore do not have parentheses after the type name. All the members defined for your interface must be abstract, and this is a formal requirement for F#, but it's implicit in C#. And here you can see we're defining a method named teach, which takes a string and returns unit, otherwise void. And you'll notice the definition syntax, which is parameters and a return value. We're also defining a property focus, which is of type string. And we must fully declare the types when defining interfaces, since we have no implementation to provide content for F# to infer anything. To implement an interface, we use the interface with keywords as part of our type definition. Here you can see our implementation of the iTeacher interface. And just like C#, we can implement as many interfaces as we want. However, the implementation is always explicit. Therefore, to call any of the methods defined for an interface, you have to cast the object to the interface type. And the methods and properties are never exposed in the public signature of the object. To access the functionality provided by an interface, we either need to pass the object into a method expecting that interface, or perform a cast on the object itself using the cast operator. And here you can see the cast operator, which is really the colon and then a greater than symbol. I like to think of it actually as a little bird beak, and that's how I remember it. But here we're creating a new instructor and calling the iTeacher teach method. One issue you may run into when architecting your applications with types is type ordering. Because F# only allows you to use types which are fully defined prior to the current definition, you can't create cyclic dependencies like you can in C#. And here's some fairly simple and common C# code which has a circular dependency between invoices and products. So this code is by default not allowed in F#. We could use it from F# but not define the types this way. However, there is a trick that you can use. The AND keyword lets you define two or more types together all at once. And this allows the circular dependencies to be created. And this approach complicates your code and it's really highly discouraged for F Sharp. Instead, what you should really do is try and refactor the code to not use this kind of dependency. If, however, you're defining this based on a required structure, coming perhaps from another language where this is more common, you can do it. Now let's take a small quiz about what we've learnt about interfaces. Question 1. F Sharp types can implement interfaces. True or false? And the answer is true. Question 2. F Sharp types must A. Be defined in a namespace, B. Define a primary constructor as part of the type definition, or C. Both of these. And the answer is C. Both of these. So we've looked at namespaces and types. Now let's focus on the third element we use in F Sharp programs, modules. And it turns out that we don't actually tend to define a lot of types in F Sharp. That's really an object-oriented concept, not a functional one. You can define types, and sometimes it's valuable to do that, particularly when you're exposing things to other languages, but more often you'll find yourself just defining your code in modules. And a module is a grouping of related F Sharp things. Those things can include types, values, and functions. And this grouping helps keep related code together. It avoids name conflicts and promotes the functional nature of the language. And in many ways, you can consider modules to be similar to namespaces. They accomplish many of the same goals, in fact. However, modules are not namespaces. Instead, they're really creating static classes with public static methods, fields, and inner class definitions. And that means they can't span multiple files like namespaces can, but they can include things other than types, such as let-bound values, unlike namespaces. F Sharp programmers tend to use modules over types in F Sharp specific code when working with or exposing functionality to other .NET languages. And that's where they'll more often create types. Here's an example. We define a geometry module which has an inner module named utilities, which has two functions, area and perimeter. In code that's defined after this module and file, we can then use geometry.utilities.area to calculate the area. Now this doesn't require any class instantiation and it's not object oriented. So I can't replace or override or extend the functions. I could also call area by using the open keyword to drag in the module. It works with both modules and namespaces and allows me to make visible types and values declared within a module directly accessible to my code without me having to fully qualify it. F Sharp programmers prefer this approach because it tends to be more functional. I can use these defined functions, area and perimeter, without creating an instance, and I can link them with other functions to perform my work. So let's look at some of the key differences between modules and types. So let's look at the differences between modules and types in F Sharp. As you can see, we've got the two table columns on the left for modules and types. So for modules, they're not really necessary to appear in a namespace, but for types, they have to appear in a namespace. Now modules, you'll find them more commonly used in standalone F Sharp projects because they're easier to work with in that more functional approach. The types though, they're easier to use when you're interoperating with other .NET languages like C# or VB.NET. And modules are also common to nest inside one another as well, and you saw that in the area function just in the previous few slides. But with types, it's uncommon to nest types within one another. So here's a full example that combines all three of our elements together. So you can see the file must always start with a namespace or module definition. Types must be declared either in a namespace or in a module. And we can have types contained within the module that are specific to the module. But if you want all modules in the contained files to access the types, they need to be scoped outside the individual modules. And you can see that modules can hold types, values, and also functions. For our last lab today, we'll be creating a module that we can use and call from a console app. The module will add all the numbers passed into the command line and then add the numbers together. So while it's a straightforward lab, its main benefit is to show you how to create and to call a module in your own application. And you'll find it under exercise 3 in your lab notes. So just like before, go ahead and pause the video while you do the exercise and then resume the video once you've completed it, and then we'll review the material. Excellent. So welcome back. Hopefully by now you've finished the third lab and you should have ended up with a solution that looks a little bit similar to what's on the screen. So on the right hand side here we've got our module called adding, and it's got a single function called add numbers, which takes an argument, which is a string array, and then we use some pipelining to get arguments and then map all the values because they are strings and we need them as integers in order to add them. So we're using this map function to map the individual elements into their integer counterparts, and then we're using the result of that using pipelining and then pushing that into the array sum to get the total. Now we could also use the sum by within F# on the array to actually do the same thing, and that's actually a little bit useful. There's a lot of these great functions off the array type that you can use to simplify things too. And on the left hand side here we've got our program, which really just prints out all the arguments that have been passed, and if the argument length is greater than 2, then it'll print out the result of adding all those arguments by actually calling into that module. So you can call into that module because we're using the open keyword at the top and referencing the module name. And you'll notice on the left hand side as well, adding is listed just before the program. So that's going to read in the arguments. I'm just going to go into the project options. I'll just double click on that to bring that up. Select on the run and then general, and you can see all the parameters that we have in here, 1, 2, 3, and 4. So that's when it is going to be passed on the command line. I can then run the application. And there we can see the arguments, 1, 2, 3, and 4. Let's finish today's video by doing a quick flash quiz looking at modules. Question 1. Modules, A, are made up of classes, types, and references. B, contain values, function values, and types. C, must appear in namespaces. And the answer is B. They must contain values, function values, and types. Question 2. The member keyword identifies A, properties and methods in a class, B, a constructor to create an object, or C, defines a class. And the answer is A. The member keyword identifies properties and methods in a class. So in today's last objective, we had a look at namespaces, we had a look at types, modules, and we compared the differences between modules and types. In today's video lesson, we learnt how to structure and manage your F# projects. We also looked at some of the templates that you can use, and also had a look at types and modules. In the next class, you'll be looking at how to create other data structures that'll let you take advantage of more of the F# functional capabilities. So congratulations on completing another F# class, Projects in F#. I've been Glenn Stevens, and thanks for watching this video from Xamarin University.